Okay, so this is the solubility lab. What we're going to be showing here is we're going to take a solid, namely salt, and we're going to dissolve it into a liquid, water. And we're going to notice some differences on how salt can dissolve into water and how it comes back out of solution depending on different variables. The one we're going to use is temperature. So, first things first is we take some salt, and this is cold water here. It's important that it's cold. And we're going to shake just a little bit of salt in there and see how it dissolves. Okay, take our fork of science here, stir it up. And see what happens. And you'll notice that all the salt is still there right in the middle where it's swirled in. Here, can we look over the top there and see it? Is all the salt's still in there. It's not dissolving. The water doesn't really want to take much salt right now. It's cold, it's tired. So, what we're going to do is we're going to now warm this water up and see if that changes how the water will dissolve salt. So I'm going to take this to the microwave, I'm going to put it in for a minute, and I'll be right back. Okay, so now the water is hot. I actually ended up putting it in for a minute and a half. And we're going to shake some more salt in, see if the water wants to hang out with the salt any more than it did before. So here we go. Shake some salt, shake some salt. You'll notice the difference now already is the water is getting cloudy. Something different is happening. So here I'm going to stir it up. Get everything mixed up here. And now, let's look in there and see what we can see. There's no salt, or rather the salt is all dissolved into the water and become equally mixed in, as it's not staying together in chunks sunk to the bottom of the glass. So it sucked up all that salt. We're going to add even more salt and see how far we can keep going here. All we've done is we've increased the temperature of the water, as we didn't do it quite to boiling, but pretty warm. And now all of a sudden, we can put a lot more salt in than we could before, as the solubility of this situation has increased. And what exactly makes that happen is gets into some pretty advanced chemistry. You get solubility constants, and depending on what kind of substances you're working with, it's different. There's a lot of different things that can affect it. But the very simple thing that we're trying to show here is you warm up a liquid, and it can take in more of a solid. You can dissolve more of a solid. So see here, we've added a bunch more, and still we don't have any salt there on the bottom of our glass. So we can put in even some more here. Getting really, really, really salty. Keep on stirring it up. Takes a little bit longer to dissolve now that we've got so much salt already in solution. But even there, you can now look, and it's all still dissolved again. And we could keep going on and on like this and keep adding more salt, but eventually the water would become saturated. We would reach a point where the water is so full of salt it can't take any more salt, there's nowhere else for it to put it, and the salt would end up falling to the bottom of the glass just like it did when there was cold water. Okay, great. So now we have a lot of salt, it's all mixed up in the water. We can also bring that salt back out of the water, is what we did to make the water want to take in more salt as we increase the temperature. Well, it makes sense if we decrease the temperature, the water's not going to be able to hold onto that salt as well. It'll have to let it go, and the salt will come out of solution. It's a little more difficult to do this because even when the salt does come out of solution, it ends up being hard to see. And so what we're going to do is we're going to take some of this and we're going to put it in the freezer. And then whenever it gets to be pretty well half frozen, as there's a lot of ice there, we're going to take some of the ice out and rinse it off and taste the ice and see if the ice tastes salty or not. If it does, then the salt is still in solution. We were wrong. If it doesn't taste salty, then that water has let go of all of its salt and it's frozen into ice, and it's pretty close to back to being fresh water. So I'm going to put some of this in the freezer, let it freeze pretty good, and we'll be back in a second. Okay, so here we have some of the salt water. It's been in the freezer for about 40 minutes now, and you can see it's pretty slushy. There's still some water in there, but there's a lot of ice also. And that's good, because if it gets frozen solid, then obviously our ice is going to have salt in it because there's nowhere else for it to go. But right now, there's a situation where there's some ice. That water was hopefully able to dump its salt, and then the water that's left in there is now having to kind of take it on. So what I'm going to do is we're going to grab a piece of ice here, And there's probably still going to taste, this is still going to taste relatively salty because it's been sitting in salt water. So we're going to dunk it in some fresh water here, rinse all that salt off, and then it doesn't taste salty. It tastes a very, very tiny bit salty, but not anywhere near as salty as this. This is almost going to burn your mouth. There's so much salt in it. So we've put salt into solution. We've added more and more. We've made the solubility of the mixture go up so that we can put more and more salt, and then we turned it back down whenever we put the temperature back down, and the salt left solution. Okay, great. That is what we were trying to illustrate with solubility. It's very straightforward and easy to see. It's not super exciting. So, because we like to have things exciting, let's do another experiment here where we watch something come out of solution very quickly. And we're going to step outside for this here in a second, but the principle of what's going on is carbon dioxide is in solution in pop here. That's what makes it bubbly. There's carbon dioxide mixed up in there, just like the salt is mixed up in the water, and it will come out if we open the bottle here. It'll start to come out of solution, but we can make that happen more or less quickly, and we're going to do that with Mentos. So we expect to see carbon dioxide come out of solution extremely quickly in a relatively exciting manner. So let's go outside.
Okay, so we are outside where we're not going to make a mess anywhere. We've got our Coke, we've got our Mentos. Hopefully this worked because we're not going to do this experiment again if it doesn't work. Take the top off there. We can hear the carbon dioxide hissing out. You can see bubbles starting to form. It's starting to come out of solution, but not anywhere near quick enough for us because we are always in a hurry. So we're going to drop a few of these in there. And there we go. It came out of solution quickly as the carbon dioxide left the liquid, and we had a geyser of Coke and foam and carbon dioxide, and it was the Mentos that helped us do that. Why? It gets kind of complicated. But what we're trying to look for here is something comes out of solution very quickly or not so quickly. Whenever we just opened up the bottle of pop, pressure decreased, carbon dioxide started coming out of solution, but whenever we added this other factor, these Mentos, came out of solution much, much quicker. Just like we can put salt into solution, or we can put salt into solution very well by increasing the heat of the water. So that's all. That's the solubility lab. The end.